committee, which is what's the industrial committee and what's that we do, since it's a recently young organization. Back in 2014, 3 years ago, an industrial committee was formed with these three main tasks to achieve. That are, first of all, strengthen the engagement of industry in Ifac. This means to have industry people sharing their experience and knowledge within the Ifac. And on the other hand, also seeing how Ifac could benefit the different industrial sector. So having Ifac really share their knowledge and experience with the different industrial sector. So the goal, finally, was for everybody to cooperate in order to achieve controlled research, the realization of controlled research of its full potential within the various industrial sector. So to do this, Tariq Samad, as a chair, led this effort with 38 people to really go through and see how could this be done. So what did we do? First task, analysis. We try to analyze the present situation, which part of the control technologies are today used in industry, and what are the limiting factors that don't allow this to be further spread. Second, based on this input, we organize a set of work streams to address the various parts. And the thing that today we would like to share with you, but also get your input on, is several of ideas and points that were identified, and understand if you have a similar experience and if this works also in the setup where you are typically involved. Finally, one word about the future. So last Monday, the General Assembly of Ifac actually approved a permanent committee. So we are going on with our vision, and we are accepting new participants. So if any of you is interested, please contact Tariq, contact any of us, and we'll be happy to welcome new members. So, about today, this session will provide input, but also is expecting you to give some input. And we have an excellent set of panelists today. I'm really happy to work with them. So, first, Dr. Alex van Delft is a corporate manager on DSM, working on process control, so European process control. Dr. Michael Lees, automation manager for Carlston United Brewery, process control from Australia. Dr. Takashi Yamaguchi, corporate advisor at Ricoh, working on mechatronics from Japan. Professor Thomas Jones, CEO of S-Plane, working on aerospace control, coming from South Africa. Professor Sebastian Engell from TU Dortmund, process control in Germany. And Dr. Kevin Brooks, chief engineer at APC, on, again, mineral processing from South Africa. Myself, I work as a professor at the University of Applied Science in Switzerland, and my background is control for power, energy, and robotic systems. So, having said that, I now leave the word to Alex to give an introduction about the rest of the presentation.
Thank you, Silvia. And thank you for the tooling. Well, when we were invited to have this roundtable discussion, because that's what it is, I'm warning you already beforehand, we thought, okay, that will be a cozy conference room where we can listen to each other, interact with each other, but we didn't expect, of course, this gigantic auditorium. Nevertheless, this will be an interactive session, and the interaction level will depend upon you, because we will do some talking anyhow. You can expect that. We have nice slides, nice layout, nice setup, but we need interaction. We need also your inputs as to the industry committee, because industry, academia collaboration for us is key. That's what we sincerely believe, and that's what we would like to discuss with you this morning. And since we want an interaction, the backbenchers, they may come down if they are open to do so. There's plenty of space here in front of you, so if you have questions or remarks, probably easier to do that in the front rows than in the back rows. So we heartily welcome you to step down, to come down, because there's plenty of space available around here. What are we doing this morning? We have, of course, the industry committee intro. That's what Silvia did. The panelists, you've seen a very broad spectrum of people, branches, regions. Although I saw that America was not well represented. I don't know why, I don't know what happened. But anyway, Tariq is at least representing the America, so that's in the end coming very well up. I will do a quick intro of the session setup. We will have an open question to the audience. So we also expect some answers and suggestions before we will go into our ideas. We have perspective statements from all of the panelists. We have a roundtable discussion, and we really would like to come out of this session with a couple of suggestions, a couple of key topics, a couple of key issues that we would like to also take along with us in a follow-up session, which is organized by Tariq for Friday morning, I believe it is, Sorry, afternoon. Oh, okay. You can still do some just before the end of the conference. So that will be definitely the takeaway for all of you. Good. And the question is, of course, take a look at this slide, please. Do we have an issue? Do we have an issue in industry, academia, collaboration? Or is it going fine? That's also great, then let's celebrate the successes. Do we have an issue? We need your input. So please share ideas and thoughts on what we believe are the key elements for a good collaboration between industrial and academic partners. And to me, I have a confession to make. I'm not a chemical engineer nor an electrical engineer. I studied physics, and we always like natural laws. And to me, there's a kind of natural law in achieving sustainable results, and that is that you have to touch a lot of things, but these three things you definitely have to touch, and that's the people aspect, the processes, and of course here we're talking about the ways of working together, and last but not least, but that's of course not our weakest aspect, the tools and the systems and the technologies. And each of these elements you need to balance in order to achieve sustainable results. And the question is, what can be done, improved in each direction for successful collaboration? Because traditionally, I believe this competence, this discipline is very good in the tools and the systems, in the algorithms, in the theories, and in the results. But in the end, for a good collaboration, we believe you need to touch upon the other things. Processes, governance, how do we work together? How can we work together in a better way? What about the people? Are industrial people really aware of what's going on? Are we in academia really aware of what's going on in the industry? How can we improve that? How can we change our behaviors of working together? I think that will lead us to sustainable results. And before we go on with the panelists, I would like to go back to this open question and put the challenge in front of you to give, first of all, your ideas, your observations on this collaboration. So we have some nice assistants over here. They all have a microphone. So if the crowd of people that come up with suggestions stands up, we can go with the microphone to you. Please forward your suggestions. What are your ideas on how to enhance collaboration? Who would like to be the first? Okay, great. That's the first one. Please come over, and somebody else can have a microphone also to make it a little bit easier. Yeah, you can pass the microphone. Oh, great. If you want to.
Good morning. My name is John William Vasquez, and I am a doctoral student in Cotutel of the University, the Andes University of Colombia, and inside Toulouse. And I work in automation, diagnosis, and I founded one institute, the Bogota Institute of Technology in Colombia, that is the first institute related with automation and control in projects with the industry. I am the Innovation Prize in Colombia. Ecopetrol, the company in Colombia, gave me one prize in innovation for my doctoral thesis. And this relationship between the academy and industry is a need that needs to be solved, as you say. But one problem is how catch research for develop the projects. And maybe the political laws help to the industry to invest in projects. And I won't know, I won't belong to this committee and found a resource for begins to develop projects with industry. And I will know in your countries, in each country, how is managed this relationship. If there are institutes, how works in Germany, how works in Chile, how works in the United States. Maybe this is a good view of how management this type of projects in the world. Thanks.
Thank you a lot. And I can promise that there are some examples of successful collaboration in the presentations. The chance to have a glance at it. Anybody else who would like to comment? Oh, hey, now the crowd is...
Okay, my name is Paweł Domański. I'm from Warsaw University of Technology from Poland. I worked for 20 years selling, doing projects of APC process industry. And this picture that you have shown on the previous or the next slide, whatever, it's not as easy and simple. First of all, there are more parties than two. It's not the university and industry. We have also the control vendor, we have also some external parties and so on. So this cooperation, collaboration, soft skills are extremely important. And the other problem, which is from the university point of view maybe the crucial, is a different approach to the risk. University never want to risk anything. They are just doing some science, which is not risky at all. They are not risking money. In the industry, everybody is risking money. So this, for instance, we should also add another point, which is the maintenance of the project. Industry does not accept project without maintenance. So then we have a lot of dead soldiers. We did something, we left the site, it does not work. Farewell. Okay, thank you.
Good. Thank you for your very valid remarks. More parties involved. And we don't only want solutions, we want sustainable solutions that are maintainable in the end and reliable in the end. Very recognizable. Thank you.
Good morning. I come from a small undergraduate university from the United States, and I want to address the question about education, control education at the undergraduate level. There have been a lot of papers in literature and trade journals that students coming out of universities do not have the skill set that is required by industry. Industry is somewhat disappointed that, okay, universities are not supplying very well trained students. But at the same time, I think that industry has to take some responsibility and have some guidance as to what things should be taught in the undergraduate curriculum. So my question to the committee here and to the Ifac Industrial Committee is, are there any plans to come up maybe with a white paper or with a suggested curriculum that industry would like to see addressed on the undergraduate level of education?
Anybody else out of the panel who would like to react on it? Please.
Is that on? I think that's a very interesting question. And it's something that's actually been addressed in South Africa recently. and it's actually quite contentious. And I think it's contentious because what people believe should be in the curriculum depends on what they do in industry. So what I believe should be in a curriculum for control, I'm a chemical engineer, can be quite different to what someone who works in a different field and maybe is electrical or mechatronics. So the question is the automation and control, would it be possible to define a single curriculum that would be able to be suitable across disciplines? My feeling is it's not, and that the model that we have now, where control is taught potentially by the same people, but is actually individualized to different disciplines, is actually the correct model. It's my personal feeling.
Okay, thank you, Kevin. Any other questions from the audience, remarks?
Over there, no.
Okay, the backbencher. Yeah, that's the disadvantage of being on top of everything, huh?
Hello, my name is Tiago. I'm a PhD student at the University of Illinois Urbana-Champaign in the United States. My question to the panel, and also a comment on my personal experience, is a bit of a conflict when working with industry. When at the university, what we want is to share the information. We want to publish, we want to make it public, we want to do it for free. And that a company wants it as intellectual property, wants it to be something it can protect and make a product out of it and a profit out of. And I felt and experienced that there is a little bit of conflict there. And how can we break this barrier in a way that either the university has to be more flexible, or the industry has to be prepared to fund a research, but get that result out there and maybe just be happy being the first to market or something like that.
So that was one of the things we had to deal a lot when I was working with ABB for 10 years. One of the issues was exactly always this, that critical is that the company needs the IP to survive. So if they come up with the solution and put it on a product, but then this knowledge is public, then the solution has less value for them. So there are compromises, of course, to be taken, and there are two ways, in my opinion, to compromise on this. Either there is a clear agreement that, because the university needs a publication, but the industry needs their invention disclosure to survive. So one way is really that invention disclosure can really be formulated based on specificities that don't necessarily have to be published in a paper. So the general idea can be posed as a research problem, but then the details of implementation can be kept secret, for example. And this in software and control is pretty easy. If you are patenting a piece of hardware, then it's clear, you need to describe how it's done. But for an IP or for a publication, you don't really need to see how you're going to eventually implement or the tricks that are required to do that. There are several solutions, but for sure it has to be a compromise, and people need to be willing to give up a bit on this. I don't know if you had different experience on.
If I can add to that, I think there are two more points. The one is that if we look outside of some of the mainstream universities in Europe and the Northern Hemisphere, and also inside those, there's a push and a drive from universities also to protect intellectual property, not only from companies. Many universities and governments have cottoned on to the fact that there's value in intellectual property. So there's a fortunate side to it and an unfortunate side to it, of course. The part about describing in the form of a patent a bit of intellectual property, yes, it takes time, but at the same time, once it has been described, it's also in the open domain. It's there, it's described. So what you also need to deal with is essentially that there's an advantage to describing the intellectual property, putting it down, publishing it essentially, but in the process protecting it. before publication. And the disadvantage, of course, is that there's a time delay. You end up having to wait a year or whatever the case might be to be able to protect that work that was put together. That is, if you do need to go through the process of putting the specifics into an article.
Good, thank you. Any other questions and remarks?
Good morning. My name is China Srinivasan. I am from the Ohio State University in the United States. I come from a mechanical engineering department, and there are examples of successful long-term industry-university collaboration at my institution, and some characteristics of those are a very identifiable expertise that's available in the university. Give an example, gas turbine engines, some aspect of gas turbine engines. And I'm talking about the consortia that are at my institution. Another one is on what sounds very pedestrian, but gearing, gear dynamics, gear noise, which is very widely used in the automotive and aerospace industry. And so I can identify some traits of what are successful long-term collaborations, but I'm not sure that I feel the subject here is collaboration in the controls area. I wonder if there are aspects of industry-university collaboration in the controls area that set it apart from other disciplines. And I'd be curious to know if there are examples of successful collaboration that we can learn from. So that's the question that I pose.
Thank you. Any of the panelists who would like to comment on that? Yeah. Final comment before we go to the panelist presentations in themselves. Coming back to your question, my own experience. In the Netherlands, a lot of attention for what we call the top sectors, chemical, food industry, energy, etc., etc. And control is always a kind of supportive technology. So we don't feel sufficiently addressed or sufficiently exposed, to be honest, within the Netherlands cooperation context, because it's always a kind of enabling thing. It's not something that is in the end result area, like producing energy in another way or producing food in another way. So that's the issue that we face. And it comes back a little bit, if you have a specific area, then it's easier to tie into industry and vice versa. But if it's not supported by the government, then it becomes a little bit blurry. Okay. There are no further burning questions. Of course, we will have a roundtable afterwards, after the sessions of the panelists. Hey, it's you.
It's me, thank you.
Please.
All right, I'm Thomas Jones from S-Plane Automation. I've always had a foot in industry and a foot in academia. I graduated 20 years ago, and from the start it was like that. Because of that, I'm trying to aim this short perspective statement at both industry and academia. I'm not an industrialist trying to describe to academics what it is that we need or vice versa. I think there's something to be learned from both sides and something in this for both sides. I'm not going to try to stick to my specific examples in the field where I'm in. I'm an aerospace control engineer. I'm going to try to generalize from the experience and the examples that I have. By no means is this a comprehensive recipe. I don't think it exists. I don't think you'll find a comprehensive recipe. I think what we need is to establish some basic methods for going ahead and doing what we need to do to collaborate between industry and academia, and to step back to those basics when we encounter projects and specifically when we encounter complexities. 3 slides, 3 simple points I get back to. The first is understanding. I need a Venn diagram, and exactly 1 Venn diagram in 3 slides. in this world, I'm able to reveal what it is that that I do and who I am and what I'm interested in, and I listen, and somewhere in between there is understanding. We need to take the time to understand the different industry and academic perspectives for each project, and I say for each project because it really is for each project. Everything is different. We need to spend the time on each project to do this correctly. We need to be able to foster a team mentality. It is not industry coming along to decide that they need something out of academics, and but they don't really respect what is happening or doing or being done at university, and vice versa. Industry is not just a source of funding. It needs to be a team to be able to accomplish specific goals. We need to identify those goals. We need to know how to tackle those problems and how each of us tackle those problems and why, what the processes are that we use to solve those problems, and the suitable technologies. Simple example, aircraft. I'm spending a few $1 billion developing a new aircraft. If I'm in industry, I am interested in validating what I'm doing, very much interested in validating. I need to know that I've covered the risks and I can implement what I've been working on this $1 billion investment. If for example, do flight control like I would do, then I would maybe stay away from non-deterministic control methods if I'm going to certify. I prefer to move away from those sorts of things from an industrial perspective. As an academic, I might want to look at non-deterministic control. That would be interesting to me, but maybe why that is important is that I know what the bounds are, or I can try to find the bounds of what it is that I'm able to do or not, but I need to understand that what I'm doing might not be implemented on an expensive new development. Then symbiosis, and the good kind, not the bad kind, mutualism, not parasitism. If we are going to be able to work together, we need to define projects with outcomes that are valuable to all parties. There are different goals, there are different timelines. Students are interested in their master's degrees, their PhDs, whatever else that might be. They're interested in their specific timelines. Academic years are different in Northern Hemisphere and Southern Hemispheres and so on. Academics are interested in their publications, they're interested in delivering students, while in industry, and if you look at researchers, they might be interested in totally different aspects. They fit into a larger Gantt chart of a project, advancing technologies on long technology readiness levels, and need to fit specific readiness levels into specific projects at specific times. And those things aren't at all aligned with academic years. So often what we'll see is that we need to run some form of demonstration and validation exercise if industry and academia work together. We need to be able to look at the value of both practical and theoretical solutions to all, and I'll give you an example at a moment, and the cost-benefit trade-off and the simplicity and complexity. If I, for example, look at one of the projects we worked with Airbus, on automated refueling. If you have automated refueling between two large commercial transport aircraft, two aircraft are tracking each other in the sky. They need to stay in very close proximity with a receiver or receptacle on a receiver aircraft that needs to stay within a 2 meter by 2 meter by 2 meter box in space. As an academic, I want to be able to do whatever I can to implement technologies to push the limits, the boundaries. I want to be able to handle various kinds of turbulence and all sorts of flight conditions and keep that aircraft within that specific bounded box. If I'm in industry, I might want to use the fly-by-wire system and the flight protection systems on board the aircraft and reuse them as much as possible. So there are constraints from the industry side. Now, again, what this comes down to, an example of one of the projects, like I said, we did, we could use the theoretical methods and show that that's of value to industry by finding out and figuring out what is possible, the limits of possibility, while we could then show, using the existing systems and modify the existing systems, the constraints of those systems, that we could almost reach those bounds of what would be possible. But the difference is lower cost, a certifiable system, and something that can be validated for industry. So there's value in the theory, and there's value also in the practical, simpler solution. And lastly, the reason why I do this is because innovation, in my opinion, results when valuable, when when diverse people come together and they step outside of their comfort zones. Step outside your comfort zone, that is where you find interesting things. Industry constraints are interesting. We can adapt and we can create new theory to fit inside those kinds of constraints. And when we adapt and we solve these problems, we're adding real value because we're solving real world problems. Now there's value also in solving theoretical things, but there's a lot of extra value in being able to solve real world problems. And in the end, what it comes down to me, is identifying new opportunities that I wouldn't have been able to identify in my world where I used to sit and work with my blinkers on. And at the same time, I'm then able to create solutions together with a team of diverse people that I would never have spotted before. And this to me is the carrot. This is the reason why I come back to doing this. Thank you.
Question for Thomas Jones.
Hi, my name is Lawrence Olivier. I work for a petrochemicals company in South Africa and also recently finished my PhD. The question to Professor Jones is, what should happen inside a university department, and at what point do you need to go and create a company maybe to do work, supply the solutions to industry? So where do you almost make that distinction? And
I think, like I said earlier, Lawrence, thank you for the question. It's a tough one because every project and every specific situation is different. And like Kevin said, any specific department, any specific, say, process control, aerospace, whatever, might also be different. To me, I usually go back to technology readiness levels, TRLs. If you look at these sorts of things and how they are defined, often what you find at universities is that the lower levels of technology readiness would happen at universities. Somewhere in between, say the mid-TRLs, TRLs go from, say, level 1 to level 10. Somewhere along the mid-TRLs, you get government and other research institutions that tend to bridge the gap between universities and industry. And then eventually towards the higher TRLs, technology readiness levels 6, 7, 8, 9, 10, you'd end up with companies eventually industrializing and using and selling products and services and so on. So I would go back to those TRLs, and if you're familiar with them, then go and have a look. Otherwise, come and have a talk with me. As soon as you start exiting a point around TRL 3 or 4, where you start getting into a world of demonstrators, and 5 and 6, when you start getting into more advanced demonstrators, then I think the readiness is there to industrialize, to really get to the point where you're now validating something, to a point where either you need to spin out of a university or the university needs to license what they have to industry to be able to do what they need to do. Of course, there's also the question of whether this work was done to be licensed or to be protected, or whether it was open and available to everyone else out there to start their own companies and do their own things, depending on where the funding came from and what the goals of the researchers were. Right. Thank you.
Although that the dynamic of the industry and the dynamic in the academic sector is different. How solve this problem? Because in the academic, all is slow. We have vacation. The industry go fast. New results quickly. It's now. And how try to solve this problem in the project?
I don't think it's a problem. I think it's the advantage. I think that if you again look at this TRL type of setup, again readiness levels for technologies, then from my perspective, what you need to be able to do is you need to be going to universities to look at general ideas of how to solve problems. Most of the things that are done at universities are relatively high risk, not validated technologies. We start off initially doing investigations. That takes time. It takes the odd academic to sit on a couch and philosophize with his students to try to figure out how to handle specific things. And that's the advantage to it. That's not a disadvantage to it. When industry has a specific problem, it's a different situation. When industry comes along and says, well, I have an absolute burning problem. I need to get an automated vehicle driving in the street 2 years and 2 months from now because I have a contract for this. All right, and that is a different kind of situation. That is a point where that would require. Firstly, the industry already has taken the risk to be able to do that, and and at that point you require a whole lot of investment. So sometimes that might be a project that you want to end up using university for. Other times you don't want to be using universities for those kinds of projects. I'd rather say use researchers, employ them, do the work, get your engineers, get your scientists on staff. We have roles to play along the spectrum of technology readiness, and I think there's value to understanding our roles within that space. And I'm not saying stay inside that space. I, for one, don't. I like to move along that space. But at different places, we have different roles. And it's valuable to support those roles because there is value in it. There's a place for bridging the gap between universities and industry. And if industry wants something quickly, then there must be more investment, there must be more effort and work. And of course, there is more risk. The university won't necessarily take that risk. Right.
I'm Heikki Koivo. I come from former Helsinki University of Technology, nowadays Aalto University. I have had more than 100 joint projects through the industry, and one thing that one should separate is that if you have just one company that wants the university side to do something, it's different. But in many countries, Nordic countries, also Europe, we have funding agencies. In Finland, we have what's called Tekes. It was set up under Trade and Industry Ministry in the 80s, and it used to be so that if you could have two companies convinced that, hey, we are going to study this topic, then they would fund us. First it was 80% from Tekes and then 20% from industry, but nowadays it's a little bit less. And if it is just one company, then of course these IPR rights are not that easy because industry funds you, so they want results and they don't want you to even publish if it's not agreed in the beginning. But if you are funded by Tekes, then it's, I think it comes from EU that yes, university has IPR rights, but then, and usually we don't develop products, but we call them concepts, so that many times company or companies have gone further and developed products. So if you want to do this funding by Tekes, then you have to do exactly what you were saying there. Go and market yourself to industry and find understanding between you and trust also. And it has worked very well, especially when I have about 300 former master's students of mine in industry, and I think 30 or so PhDs. And so it's easy to talk with them because they know what I know. And when I went back I'm actually from University of Minnesota, studied electrical engineering, but also PhD in control sciences. And I think that our task when we start doing research with industry is that we talk about the topic and the objectives, and then we can pick proper tools. We have many, many tools, and it depends on the goal that we want to achieve. And we have many good achievements, like doubly background, going back to Finland. In 80s it was not, or early 80s, it was not very customary that universities work together with industry, but then gradually things change, and the first research in my case was to look at TMP heat recovery system. Thermomechanical pulping is in paper making the first thing. You either do chemical or mechanical pulp making, and in early 80s, this TMP plant put half of the energy generated. You have 10 megawatt and 30 megawatt plants, and if you have a lineup of them, that seemed to be doomed. But then came heat recovery systems, and we were asked to simulate this. And on the other hand, they had a pilot plant and so on, and we were electrical engineers, but it wasn't very difficult to do us. And the one of them, the first one in the world, is still standing there in Jämsänkoski. And this continues. If you are successful once, it's like a product. So the company continued to cooperate with us and so on. But the process area has not been the only one. It has been mechanical, say, forest machines, and it has been also then other areas. And we are not afraid to tackle these new ones. And typically, well, the industry benefit is that yes, we develop these concepts, but also when we have in our team, we have usually PhD student or students, master students. Then they can see if they are very good, and they will hire them. So that's another benefit for industry. But really, I think it's not too far from what you had on your slides.
Thank you very much. Just earlier on, you mentioned when multiple companies and so on get involved, universities, and also when there's government funding, EU funding, Horizon 2020s and FP7s and all these things. Interesting, in most countries in the world, we're seeing a development of legislation towards protecting the universities and protecting the intellectual properties at the universities. Even in South Africa, the law says that if work is done at a government-funded or supported institution like universities, because they're subsidized, then the intellectual property lies with those universities. And at the same time, the law says that that there are specific ways that industry can access that technology. So they can't give you $1 and get it. There are specific guidelines towards getting access, and when it's ownership, and when there's licensing, and when there's various variations of that. So and a lot of people tend to think that that is a problem because now it tends to be regulated. But what I find is that what used to be a stumbling block in terms of negotiation that took another year to try to figure out how to handle the IP rights, because of the legislation, it actually solved the issue because it's defined. And if you know what those definitions are, you can get past those sorts of arguments and those sorts of problems very quickly.
Thank you. So the next statement would be from Alexander van der.
Yes, thank you. So let me briefly introduce my background. I think I'm the only real industrial guy over here. Not sure about that. And to be honest, I'm also not a real industrial guy because I started my career in academia very long time ago, when we still had mainframe computers in Eindhoven University. And I did my PhD in optimal control technology. And the mainframe computer of Eindhoven University was almost bankrupt thanks to my exercises, whereas it would now take just a couple of seconds on this device. But at that time, it was about dynamic optimization of solar thermal energy. And guess what? 28 years later, I think my PhD thesis now becomes really applicable, given the climate change things, of course. But let's get back to where we are now, DSM. That's a 22,000 people company headquartered in the Netherlands. Life sciences and material sciences, biggest producer of vitamins in the world, but also resins, engineering plastics, the strongest fiber in the world, what we claim to produce. Diversified company. We used to be, long time ago, a petrochemical company, and even longer time ago, Dutch state mines, a mining company, but that's a very long time ago. But given the diversity of processes and products that we have, we see challenges in automation. Challenges in terms, again, of you name it, we got it. Spray dryers, fermentation processes, but also batch, continuous combinations, packaging processes. We have it in place. Big issue, of course, in industry, utilization of the assets. How can we keep up with stability? Lean Six Sigma, one of our big buzzwords. So always have a big fight with my statistics colleagues because they think they can optimize processes without understanding them, which I think is really a sin. Continuous improvement, also a big buzzword within our industries. And what I'm saying now about DSM, that applies, I believe, to the entire Western European process industry, more or less. And last but not least, focus on sustainability targets. More and more for companies like us, it's important that we not only make quarterly profits, but also that we have our role in society. DSM is one of the big players in the Dow Jones Sustainability Index in chemicals, that you are Eco Plus, that you are reducing your energy footprint, etc., etc. These are big themes within our industry, even up to the targets of the managing board. Talking about the infrastructure, the tools and the systems aspects again. In our industry, we often call that DCS, Distributed Control System, the kind of old-fashioned name for how we automate our processes. And what we see is that we still use this stuff from the big vendors that we all have like 20 years ago. How come? We can do a lot more, but apparently we're not using the functionality that is present in this technology. Lots of attention required. We have a long lifetime with these systems, need to be migrated every 15 to 20 years, costs a lot of effort, but we want to make use of that effort, of course, to gain extra value. How to do that in a sustainable way? Work processes, also a buzzword within our industry. How to automate them, how to support them, how to translate them into real value. And last but not least, not a surprise, of course, really also a kind of competing pressure in the discipline that we have. Of course, we want more open systems, we want everything to be connected, we want big data analytics, and on the other hand, we're facing the challenges of cybersecurity, which is really a big theme in a lot of our industries. And if you look at the people, when I started at DSM, they said, we don't need this cooperation with academia because we have all the intelligence by ourselves. We used to have a big central engineering department long time ago, with a lot of PhDs and part-time professors, and we developed our own modeling language, we developed even our own control systems, but that's a long time ago. None of our industries are doing that anymore. We all rely upon the suppliers primarily, of course, but also we need to rely, and we need to rely upon you, because we don't have the horsepower anymore to develop new theories, new technologies. Fewer people, and also more focused on maintenance of the systems rather than on exploring new technologies. What we also see within our industry is really the need to capture process knowledge in one way or another. Operators in a process control environment or in a process industry environment, well, get into retirement. They have the knowledge of how the process should be run in their minds, how to extrapolate, how to really capture this knowledge in systems, in technology. That's really a big thing. Knowledge is power. And also for industries like us, collaboration at institutes, academia, and suppliers is a key thing. What do we want to change? What do we like to see also from academia to change in order to make it easier for us to cooperate? Now, I think I'm from the process industry in the Netherlands, almost the only guy here attending this conference. And I think I'm pretty sure that I'm not entirely beside the truth. And that's probably a little bit of a surprise. And I think that also holds for other countries, to be honest. So how can we tap in an effective way into your knowledge? That to me is really a puzzle. And within our company, we have some 100 people on university degree in process control. How can I bring them to the level that they understand what you are talking about, they understand what you are developing, and that they can pick the good things? So I would be in for having a kind of knowledge brokerage events, of course application and branch oriented, but I think that would be a mechanism really to tap in to the enormous potential of knowledge that there is over here. On the other hand, I think these 100 guys and girls that work for us, you can also use them in enhancing your curricula at universities or polytechnics, really having these people also onboarded and showing to your students what the practices are about. And last but not least, regarding people, I believe that in academic research, as far as I know it, the people aspect is not taken into account extensively. And if you're talking about sustainably implementing, for instance, advanced control or any control technology, it's really about the three aspects that I mentioned before, the people that have to work with it, the work processes that govern it, and last but not least, the technology, really in its coherence. So we need really reliable integrated solutions. And as was mentioned before, easy to understand and maintain. And then we also need fresh blood, of course, by the way. And you can also help us in that aspect. Okay? Processes of cooperation. And that's this old guy again, Darwin. We must be responsive to change. And of course, I don't want to eat the grass of Professor Engell, who has a very good overview of how he is working together in the European context with consortia. And I think there are more examples, and we should really elaborate on that. But it's not the only mechanism that we can apply. In the Netherlands, we have a couple of successful concepts. For instance, the campus concept. DSM used to be very big in the southern part of the Netherlands, but this industry area is now completely changed into the so-called Wildlands campus, with a lot of companies, but also institutes and universities also have institutes over there, close to the production facilities. Really an excellent environment of people being exposed to the industry and vice versa. Really a good mingling of expertises. High-tech Systems Center at the Eindhoven University, another example. Dutch Institute of Systems and Control. The chairman is sitting in this room, so you can always tap into him. Good examples of how cooperation can be enhanced. Ifac conferences in general. I must admit that my previous Ifac encounter was exactly 14 years ago when I was invited in a similar industry input panel. And the last but one was 28 years ago when I did my PhD. So I have a kind of 14-year age with Ifac apparently. And that's surprising. And I think again, you need to expose yourself in an easier way and a more accessible way to the industry people. Because you have a lot of things to offer. On the other hand, what we see in the industry, and of course we're overwhelmed with all kind of email events, internet fora, Gartner, ARC, famous institutes within our branch that supply knowledge, that more or less act as a knowledge broker, MESA, ISA, user conferences of suppliers. That's what our people generally go to, but you will not see the academia over there. So again, there's a disconnect, I believe, in how we tap into your knowledge. What's especially strong in Europe are so-called end-user communities. So people from the industry really working together on certain practicable themes. A perfect example is the NAMUR organization, which is very big in Germany and Switzerland and Austria, combining some 140 bigger process industries like BASF, Bayer, Evonik and so on. WIB, that's the Dutch example of the NAMUR. I happen to be the chairman of that organization, and we have 40 companies in the Netherlands like Shell, Akzo, Nobel, Unilever, Tata Steel, you name it, Dow, DuPont and ourselves, really producing practical guidelines. But again, these end-user communities are not well connected to the academia, and we still have big room for improvement and even for participation. I think it would be great if PhD students or master students also tap into these working groups. Last but not least, tools and systems. Again, repeating a little bit, academic research on really implementing advanced control. What does it take to really get it running in a sustainable way? I think there's still room to gain over there. We need to, and that was already mentioned in the discussion, it's not only about academia versus industry, it's also the ecosystem with suppliers and institutes that we need to play better. And last but not least, the famous paradox, we all want open systems, we want digitization. Everybody of my colleagues is now writing position papers on digitization, because our managing boards also are going to these kind of nice consultancy conferences where everybody is talking about digitization and Industry 4.0. guess what? We're all almost fighting the same thing, and we're all fighting the same battle and how to make really value out of it. And digitization, digitalisation, whether you call it, is really also a multidisciplinary thing. And I think academia can also help us in really picking the good things out of this, versus, of course, the challenges of cybersecurity, because that's a thing that we all need to fight. Okay, these were my perspective statements. Any questions, any remarks? Either you have a loud voice or you, or somebody's coming with a mic.
That's yay, thank you, first of all, for your comments, and I agree with you very much on the fact that there's a gap between academia and industry. And industry, at least my industry, the automotive industry, is still working with results from the 1960s. 99% of all systems are very badly tuned PID controllers, and there's no reason for this. And then academia has over the last 30 years, has built high walls. You're not getting in here unless you're a theoretician. You need to be a mathematician. And we're not letting you work with us on this. You can all go to sessions, and most sessions here, and we will all agree on this. Most sessions, you don't understand what he's talking about, because he's not talking about the concept he's doing. Even if it's in my own field, it seems like many people think speak as convoluted as possible, and you'll be accepted in this community. And this is the reason why data science is taking different. Because we have these walls. They do not. They have open systems. You can go and use them. They're approachable. We are not. And we could have done so many good things, because we are working in automotive systems with modern control systems technology. I can tell you within 2 weeks, you're 5 times better than the current state of the art PID. But we did this crazy wall building, and we don't have any access for industry in any meaningful way. And it's not enough to send masters into industry, because a 25-year-old person is not going to go into industry and say, hey, look how cool I am. I just learned LQR in my studies. That's not going to happen. See, he will say, how are things done with you guys? We're doing things like this. And there's later on in life, when they become 5 years later, when they're team leader or something like this, how do you talk? How do you connect? Unless, of course, and we all know this is happening, I know him from my PhD. He was my advisor in my PhD, so I'm going to give him money. That's the typical scenario. That's not collaboration. That's Trumpism. So I'm fully with you, and it's the community's fault, because we've not built accessible systems. We're using MATLAB, which is freaking expensive, and by the way, it's out the window. People are using Python. The Python map control toolbox is there, but it's abysmal. Who's working on this? Nobody here. Maybe the IT people who do big data will finally show us how it's done.
Good. Thank you so much. Believe. Okay, I think the next panelist, need to check out who's in. That's you. Hey, that's you.
Thank you, Alex. So, my perspective statement, first maybe a couple of words of introduction. I graduated from Urbana-Champaign, pretty much doing a lot of theory. So actually 80% of what I was doing was mathematical and not applicable directly, at least in that form. Then I joined ABB, thinking, yeah, I'll implement all this cool nonlinear control, and then I was shocked to see that actually, as you said, pretty much the industry was left using tools in the 60s. And I couldn't understand why, and I couldn't understand why don't you guys do that math stuff? I mean, it's so much easier. And the change, of course, happened gradually, and after 10 years there, I could experience different things, but it's still a lot of work to do. Where I work now, actually, it's a University of Applied Science, which means 80% of what I do in research has to end up on a product. Otherwise, I won't get funds afterwards. So it was interesting for me to see all the trade of how extreme can work. So I want to start my statement with a bit of a provocative question. So in my opinion, academia and industry have eventually the same exact goal. I mean, we want to push technology forward. We want to have like a good future in terms of graduating students that will continue pushing technology forward. And control is indeed a technology that is supportive. It's an enabling technology. But nevertheless, it's an enabling technology that could really put several of the industry sector forward significantly. So in my opinion, what's limiting this is effectively not the final goal, but the intermediate goals that industry are given and that academia is given. So those intermediate goals eventually also affect the way in which we get different specialized knowledge, but also the way in which we communicate and we develop our languages. So as a result, I don't know how many of you experience this, I experienced it many years now. We have a table in which we have an academic person, we have an engineer that will have to implement a solution, and we have a manager that is responsible for the budget. We are all there for the same reason, we all want to achieve the same thing, but we have barrier even in the way we communicate, because of course, the manager has to think that the balance, the money that he invested are making sense, otherwise the company will go bankrupt. The professor, or the researcher in this case, has been intensively working on just producing a result without really communicating on or having to worry how it's going to be implemented. And then you have the poor engineer that is trying to figure out if he has to do it in fixed point or floating point and how difficult it's going to be to implement this, or if he can simply live with the status quo. And again, it's not about bad will, it's really about the way we got brought up with this wall. So we are all forced to play what I would call a finite game. So for a company, it's enough, oftentimes, to have a fast solution that is probably not so advanced, but is just good enough and fast into the market. Because they want to be the first, they have to be the first to survive. Or I think they think that they have to be the first to survive. And this can have priority over having a more advanced, long-standing solution. On the other hand, for academia, it might have priority to being able to publish a paper and publish it fast, over having a paper that eventually is supported by a real application. So the question is, can we transform this finite game in infinite game? And what will it take? Can we change our intermediate goals so that effectively we are able to mix both knowledge and produce something that is long-lasting? Can we play an infinite game in which we are able to have sustainable solution and quality? Of course, taking some risk that someone might come with something before us. I have two successful models that I experienced and I would like to share with you today. And I think maybe there are some ideas that can be taken and applied in other parts. But let's see. So the first model I experienced when working at ABB, and it involves a large corporation. The characteristic of a large corporation was that, first of all, they could afford their own R&D. So they could afford a research center with people with PhDs that could really act as mediators and communicate with university. And then we have a university that was willing to do this cooperation, but also interested in having their part of their result, at least, living in a product. And a critical part was effectively that the interest, the reciprocity of working together, but also the company was able to sponsor PhD at postdocs. So it was able to provide money so that these people could graduate. And of course, part of the research could be totally theoretical and not effectively directly applied. But first of all, we'll give the industry the current know-how. And second of all, we'll guarantee that some of those solutions could eventually put their technology forward. Second example, I'm experiencing it now in my current position. So it involves mostly startups. So we are talking about now small or medium-sized industries, and again, a university. The key point here is that, of course, the small industry doesn't have the funds. So in this case, we'll need governments to chip in and take care of the budget. But then, a small company has the benefit that effectively they survive on innovation. Innovation for them is key. They're even new or they're dead. And of course, being smaller, they're also more flexible, more agile, willing to try and take more risks. So these two models eventually, in both cases, led to student graduating and developing, industry having their product, a successful product, and like meaningful publication in good journal where possible. So effectively, the cake was probably split and was a win-win-win situation for all. So this concludes my statement. And if you have any question on this, or we can move forward to the next speaker.
Thank you for your perspective. And I just want to make a remark on the mission that you mentioned, that both industry and academia, they want to advance technology and knowledge. But let's not forget that universities have another mission, and this is to educate undergraduate students.
Yes.
And if without the undergraduate students, universities will not exist. This is my first time attending this Congress, and I think that the undergraduate students are almost forgotten, and we forget that we really rely on this. I want to kind of comment on the previous speaker. I really like the point that you made about people. And it also ties with why we have PhD controllers, because this is what we teach on the undergraduate level. And so when research and academic comes with these great ideas about advanced control, people who are on the production floor, they don't understand it, and and if they don't feel comfortable with it, they're not going to implement it. And so I really want to encourage this committee and challenge you to look at the other function of the university, undergraduate education and undergraduate curricula. Thank you.
Thank you. Just one point maybe I will add to this. It's true that this is a goal for industry, for academia, but this is also eventually beneficial for industry, because industry itself won't exist if the academia won't produce students. So I think, again, it's a goal that could be pursued commonly. Thank you.
So good morning. My name is Takashi Yamaguchi from Ricoh Company, Japan. Actually, I have been working for Hitachi for over 20 years, and at that time I have developed hard disk drives, head positioning server control. Then I moved to Ricoh Company, which is a copier and a printer company. Then I have been developing the printers, the mechatronics technology, and control technologies. So I'd like to today explain using the 3 slides. The first one is the time frame. So product development phase, as you may know, there are mainly 4 stages. The left one's very early stage. So at that time, corporate R&D may need a good seat from the university or other academias, and it is very important for industry to have the joint research to incubate the seeds with the academia. So at that time, the sending engineers to academia would be most appropriate to get the good seeds, or and also educate the engineers. But the point is that how to find a good match. So usually it's not so easy to open the needs from industry. But how about establishing? How about having such as issue raising presentations from industry at the conference? So usually the conference has research outcomes that are presented, both from industry and academia, which is quite common. But maybe that kind of the question presentations might be useful or effective. The second, the early stage, definitely that as a company built at the so-called prototyping and the verification of that of the function using the prototype is most important at this stage. So at that time, not only the function specification, but also the robustness or the cost or the productivity. So from the various viewpoints, you need to verify. So in that case, maybe sending academia faculty member, the young professor or even PhD or post-PhD students to industry and to look at around the various aspects and to see if that the prototyping is good enough for the mass product. So it was like that. So that but because at that time we have to keep the certain speed. So it might be better to come that academic people come to the industry and keep joint research. So but at that time, I'm a little bit afraid that is there any evaluation system in industry? So because that was very important for industry, but may not be so well. I'm not sure well evaluated in academia. So the next stage, the development stage. So this is definitely a company can have to do that by himself. So the next is after development. So after development, so industry, it may be necessary for industries to generalize the technologies developed by that kind of product. So meaning that generalize the much more sophisticated simulation tools or some kind of other modeling or like that. Through this development would be much more valuable for industry. So in that case, maybe the industry need to get help from the academia. So in that case, the skilled person from the industry may be a good bridge between that company and academia. So we have to grown up that executive engineers in the industry. That is the point. So the collaboration scheme should be changed along the product development phase. That's the point which I'd like to explain. So the next is category. So technology development based on matured or confirmed technology design. This is one point. And so, so in that case, how to close the loop? So it is very important for designing that the system, dynamic system, and once if the academia's people join that product development after after confirming that basic design, it might be too late. So academia professors for the many experiences in various industries should join that the product design at the initial stage. In order to do that, one idea is to confirm the consortium. So consortium is very useful to discuss pre-competitive technology roadmap and with companies and academia. And from this point, the academy should join that product development. Once the product itself is fixed, then that consortium is, we have to separate from the consortium, but at the initial stage. So the next is a technology development based on the newly proposed method. So this technology, such as artificial intelligence or the machine learning, or like that, these are very stimulating advantages, but sometimes the drawback may be hidden behind that the advantage. So industry would really would like to know how these technologies are useful from the viewpoint of the same specification or the performance index which feedback theory uses, such as robust stability or sensitive function or disturbance suppression capability or something like that. So in that case, the industry really would like to ask the academy to check or analyze. So these are newly proposed technologies from that point. The last one. So in this panel, so we have discussed industry-academia collaborations. Yes, but from industry peoples, to start a new business, of course, many companies have to start a new business other than the traditional businesses. So in order to do that, so there are the 2 points. How to acquire new technology for that new business. And the second is how to transfer existing strong technologies to new businesses. So the first one, the industrial academia collaboration and M&A and acquisition would be very appropriate to acquire new technology. But to grow up the new businesses, it is necessary to connect the existing strong technology with the new business technology. So the second is that technology transfer needs the deep knowledge of how the technology can function on that process. So the industry collaboration and academia can be a very good bridge, because we industries should look around or walking around the various technologies from the different industries. Then our technology may be usually once the industry just focus on their own industries, they do not may not understand the real strongness and extendabilities of that technology he developed. But once that they are working around the various industries through this conference, then I may understand how our technology could be extendable to the new business or like that. So that industry-industry collaboration, so the mutual communication systems, maybe on this conference, might be one opportunity or the possibilities to discuss these ideas. That's all. Thank you very much.
Dr. Kevin Brooks, please.
Thanks, Silvia. Well, thanks very much. And this for me is deja vu all over again. So I was part of the organizing committee for Ifac 2014. And at that point, Tariq asked me to be involved in the pilot committee that Silvia talked about. And we had very much a similar panel discussion that day in Cape Town. And my overwhelming impression is that the issues haven't changed. What's very important, though, is that the Ifac structure under which we are going to work has changed. So that was a pilot committee. Should we do it? What are we going to do? Now we know what we're going to do. We've amended the Constitution to do it. And I think this is important in the sense of people, processes, and tools, that we now have if you like, an acknowledgement from Ifac that this is important to do. The other role that we very much talked about during our meeting about the industry committee was how do we relate to the other technical committees within Ifac? And we talked a lot about that, but we didn't talk about the education committee. And I think the one thing that's come up today, this gentleman has brought it up, is there is a role in undergraduate education that I think we've neglected up to now. We really need to bring on board. And we do it by talking to the right committee within Ifac to get that collaboration going. So I didn't put down very many ideas, lots of slides. I wanted to shoot some things out. The time frame issue is common to almost everything all of us have said, that in defining projects between industry and universities, the time frame is an issue. Well, to me, the answer, it's not simple, but what industry should be looking for is to define projects that can occur in the timescale that's possible for a university to do, and vice versa. That the university should be looking to do things with industry that can happen in the timescale that suits industry. Michael has mentioned sponsoring or moderating students. That's one thing that's quite easy to do and starts the collaboration. So I think that we have to be inventive in that way once we have acknowledged that these collaborations are important. And I kind of assume if you're here, you have acknowledged that. Otherwise, you'd be somewhere else. I'm also with Michael on the point of view of, at these conferences, we see very, very clever methods applied to processes and areas where the domain knowledge is not there, or very simplified, and it's what I call the curse of defining a model, then defining a controller where you use that model to define the controller, and then showing that the controller can control the model. That's the curse of simulation over there. And I think we have to get away from this. I'm no longer convinced by your MPC, or my MPC for that matter, where it can follow the set point and then I can put one disturbance in and it actually doesn't mean anything anymore. And we need to find a way of getting data from industry to university that they can then use to validate clever new ideas using real data. Because simulations don't do it anymore. Some other ideas, when I was a young lecturer, when I started, I wasn't working in control. I'm a chemical engineer, I was working in process design, and I spent 6 months at an operating company in their design department, which I guess was the equivalent of a research department. That meant a lot to me. Those 6 months made a big difference in my career. So I think those sort of very real collaborations, it seems to me, I mean, I don't want to pick out a company. I do want to pick out a company. It's not a company I've had anything to do with, but it seems to me ABB are very good at those sort of relationships, and getting people, university involved. So in terms of models, we should be looking at that. And then one idea I had, and I really don't know how doable it is, but I want to throw it out there for people to think about. In the process simulation world, and I'm talking about chemical process simulation, some of you may know of tools like Aspen Plus or Pro2, or these are tools used for simulation of chemical processes, largely used for design. And they have blocks which represent a chemical reactor or a distillation column and so on. And so the block solves the set of equations, the rigorous set of equations. But if you want to model your particular widget, you can write the equations and wrap them. And if you use a particular framework, which in that environment is called Cape Open, that Cape Open block can be plugged into that simulator just as if it had been written by whoever. So that allows for interchangeability between companies of their models. And that's proved very useful in that area. And I see a lot of people writing algorithms that do all sorts of cool stuff: fault detection, sensor validation, MPCs, eMPCs, NMPCs, even RMPCs. And I just think, well, if we want to get these people to use this stuff, why don't we write a platform, or why don't we define a platform at least, in which some of the hard part of interfacing it to a real process and getting everything to work has been done for you, so that if you write it in a particular way, if you write the piece of software in a particular way, you can just plug it in and it will work. And I think that might be kind of a useful practical thing to start getting researchers involved with doing stuff in industry, and also reduce some of the risk, not all of the risk. I don't think Airbus would do this, but maybe Carlton Breweries would, I don't know. So these are just some ideas I'm throwing out. I think this is an exciting time, and I resonate with someone who was saying the data analytics people, the predictive analytics, big data have become buzzwords, but when you actually look at the stuff, I don't know, but they're out there and they're working with each other, and we could be, we're just not. Thanks.
Thank you.
Okay, being the last and having only, 10 minutes left in the session makes it a little bit difficult. So I have actually reorganized my presentation at least 3 times while sitting here, reducing the time frame. Okay, so I will try to be very brief. I'm from the same background as many on the podium, so working with the process industries. I have been a professor in a chemical engineering department for 25 years, but coming outside of this domain. And what is important is 2 things. So we have done a lot in publicly sponsored joint R&D projects, especially EU-funded projects, and there are many, many schemes, and they work overall, I would say, very well. Not every individual project does, but overall, I think in Europe, in Germany, we have very good opportunities to collaborate with industry on the basis of some supplementary, sometimes even full public funding. And yesterday we had the industry committee meeting, and Tariq was very surprised that I repeatedly made this statement that overall, I think from the point of view of collaboration, we are doing quite well. And I just would like to explain this. About 25, 30 years ago, when I was a postdoc, there was an annual meeting of the German professors in control. Okay, and to this meeting came the upper middle management of the automation departments of the big chemical industries. And they would just sit there and say, all you're doing is nonsense and we don't need that anyway. Now, this has changed completely. We have very good relationships with people from industry. We understand each other. We understand the constraints. We don't want to impose that everything we are doing is relevant for industry, nor all problems of industry are relevant for academia. And we managed to collaborate quite successfully in many projects. I will not go through any of them. It has been mentioned already, one needs mutual understanding of the roles, expectations, and limitations of the other side. And it has also been mentioned, and that's, of course, from an academic point of view, sometimes frustrating, that there are many boundary conditions, constraints that have to be taken into account, especially, and also this has been mentioned, that solutions have to be run for a long period of time, they have to be maintained, and not everything that is nice and provides some improvement will be used. It has been mentioned that legal IP issues are not easy to handle, but my experience is that usually they can be overcome. We have frameworks where you have little choice. This has also been mentioned. And to build up trust and understanding, of course, takes some time. It has also been mentioned that it's easy to work with former PhD students, but not because those PhD students usually love you and are just fun to give you money, but because simply you have a basis of understanding and the same philosophy how to approach problems. Okay, so clear understanding of the roles has been mentioned already. I still believe that our most important contribution as academia to the progress in industry is to provide people, to provide the PhDs who are staffing the relatively large advanced control departments, for example, in the German industry. And real-world implementations are not our key business. This has been mentioned on the higher TRL levels. We are not the right people to talk to, and we should not pretend. And that's why I think we should usually not go beyond prototypes. And what is, I think, really important, especially with the chemical industry, is that, and this has been mentioned by colleagues already, we have an ecosystem there. There are the end users, but then there are the large vendors, and the end users will not or hardly use anything which is not supported by a major vendor where they believe that the vendor will be around in 10 years' time. And so even the role of SMEs in the process industries is difficult. Okay, so do companies take something from an SME unless they use the basic software from Aspen? Usually they will not, and I think that's a problem. Okay, why does that not progress? And what I would like to end with is that actually there are two so-called, in Europe the buzzword is the valley of death between the funded research and then the real innovations. And I find that actually there are two. One is that you go from the academic research, from the simulation, to a prototype, to an application, to pilot scale applications. This is something which is supported by publicly funded projects, and it's something that I think we can do. We can be strongly involved there. It depends on your desire to actually overcome the practical problems, and this can take very long. We all know that there are many issues until you can really run a solution. But the more important step maybe is to come from this demonstration to a product or to a service, and to develop that clearly is not the main task of academia. You need maybe research institutes, spin-offs, vendors to do that. And for me, the point where I would like to see some improvement actually is the collaboration on that side between the vendors and academia, and more take-up of solutions, faster take-up of ideas, experimentation with ideas from the companies that somehow bridge between the research results and the actual implementations by providing solutions. So when I said in the beginning, I'm quite happy, that's the point where I'm not so happy, and I would be very happy if there would be more opportunities to enter, let's say, the prototype state, even with the vendors and similar companies. Thank you very much.
Hello? Okay. Thank you, and I believe that you're quite happy with the collaboration. My question is, what is a successful collaboration for you? Because just because money is flowing, you can say, oh, money is flowing into projects, so the collaboration is successful. Okay, that's a good definition. It's not my definition. I can tell you my definition. My definition is results end up in products that I, my friends, and my family use. And they don't. Money is flowing. Hell, money is flowing in the automotive industry, my industry, like hell. Nobody takes publicly funded research products seriously, but we do it. It's money into our pockets and your pockets. But it's not ending up in products. So is the collaboration successful?
Yeah, I mean, that points to the last issue I also mentioned, which I think there are still deficits. For us, I mean, our role primarily is, as I said, produce knowledge. And if we can do a demonstration of some new ideas, of some new control algorithms on a real application, from our point of view, this is success. The problem then is, and maybe even smaller things. We have in one of the EU projects that I had on the slide, we had 4 application cases. In 2 out of the cases, we have developed solutions which are operated in daily practice in industry. Okay, one of them you can say was, let's say, on a smaller scale and was developed in the project. The other one was a large-scale optimization, not done by us, by a colleague in Spain, of the hydrogen network in a refinery. And it's actually operational. Of course, you can also do more, but the solution has been implemented. But this was not the outcome of this single project. It was the result of a collaboration, I would guess, over something like 10 years, with various degrees of intensity to create the understanding on both sides, the trust, etc., etc. But some of it already led to real results.
And not to take any of your achievements away, because I don't know you, and I'm sure your results are very good. I have no other reason to believe that. It's just a question of what is success. I can tell you about my field. So here we're in control, and some flatness was the big great thing like 5 years ago, and so to this day, in the classroom for students, it's been taught, oh, this method is used in industry and we're very successful with flatness, and it's just one example. And no, they're not. I know these projects. They've done one collaboration with a student and they think that's using it in industry. It's not. It was shit. It didn't work and we threw it away. And so the question is there a product you can buy with a modern method? And I don't know of any. And that's my issue here. That's why I'm here. I don't know of any product that I can buy that makes my life better and the life of other people better because the control is modern. And I don't know any.
Okay, I think for our industry, there are many products from vendors that implement a lot of modern technology, but I'm not so much into consumer products.
Hello, thank you. I'm Rebecca Margits from the University of Lincoln, and I wanted to add to that discussion and also to the things that Sebastian has said and also Kevin before him. In the UK, we actually have a very rigidly defined concept of impact. So British academics are assessed against the Research Excellence Framework, and which includes this impact, and in order to gain funding from the UK research councils, we have to demonstrate impact. And this means that we need some kind of statement or evidence. And again, they are really looking for evidence. Journal papers do not count as evidence. that the work that we've doing has changed what's happening in industry. And that's actually incredibly difficult, because I know from my personal experience that advanced control is used in industry, and I know that I've had to sign non-disclosure agreements. My university has signed non-disclosure agreements. I've been banned from talking about it at conferences. Many of the companies that I've worked for have been absolutely terrified by the prospect that I might present some of their data, to the extent that I was here a few years ago at SAE Aerotech, and I was in a track with one PhD student after another presenting graphs with no figures on the axes, talking about generic products that they were not allowed to name, unable to validate their results against any kind of real-life product. They were having to either validate against simulation or just say, oh, okay, I think this will work. But actually that work had been done. It was just behind closed doors, and everybody was banned from talking about it. And this is a huge problem. I know that myself and my colleagues, we do great research. It's being published in top journals, it's being presented at academic and industrial conferences, it's being taken on board by industry. But when I go to a company and I say, can I please just have just a letter saying that you've used my research so that I can submit it to this REF, or so that I can get some funding, they will not do it. They are absolutely terrified of it. It's great to hear that actually there's some successful collaborations down here, and I'm going to look up those companies because I think that's very encouraging. But I still think there is a lot of fear in a huge amount of industries, and I would like to perhaps hear some perspectives on how we overcome this. I note that you say it's quite tedious dealing with intellectual property. How on earth do we get industry to allow us to publish our data?
Maybe the industries are different. I have not encountered a single case where industry has banned publishing completely. I mean, sometimes the cases are not exactly the cases of interest, but we could even use some data, not always all data, and for reporting purposes in projects, they also did more of disclosure. But maybe the industries are very different in this respect, and maybe there are also national traditions which are different. But maybe somebody else on the podium has more.
I was going to say basically the same thing. I've not run into what you're describing, and I'm in the middle. I didn't say that I'm effectively a vendor. I hate the term. I'm a consultant. You know, we like to publish. It's good for our company, and we very seldom run into a situation where our end user says, no, you can't do it. There may be some of what you're talking about with confounding the data in some way. Or in some cases, you can use the data, but you can't just say it came from us. But that's fine. So, but I think this is a very interesting area, because I'm saying we need to give universities data so that they can do much more real work, and you're saying we'd love to have the data, but we can't get it. That is a very interesting area for this committee to look at. I think that bone of contention is very important that we solve it.
Okay, thank you.
I would like to thank you everybody for participating. Our panelists, thanks a lot for sharing your experience, idea, and excellent proposal. We will have a final summary, but really pretty much those are the points that we could see together with our panelists in terms of what we can do with people, processes, and tools. So we will go ahead and take your ideas, summarize them, and then move forward to the next step for the new industrial committee to take further step in this direction. Thank you very much, everybody, and enjoy the rest of the conference.